Factoring polynomials of more than 3 terms. So sometimes this could be something like grouping. Sometimes this could be considering portions of it and seeing what we share in common. So say, for example, I have 4 terms. I'm going to try grouping first. In the front term, I can pull out a 5a squared. This leaves me with a plus b. In the second term, I can pull out a negative b squared. This leaves me with a plus b. Since these match, this set of grouping has worked. So they become one term. What I pulled out front becomes the other's term. If it weren't for the 5 here, we would actually have a difference of squares, but because of the 5, we don't. So it's left like this. Another example would be something like 9v squared, 9u, u squared, minus 48u, plus 62 minus v squared. So we have 4 terms again, but you'll note that if we start grouping, we aren't going to end up with a situation like this. It isn't going to factor. So one thing we're going to do is just consider the front 3. First, do they share anything in common that we can pull out front? No, but 9 times 62 gives us 558. Factors of 558 that add to equal 48. We can try different pairs, see if we can find one that works. So 62 times 9 divided by 28 divided by 29 divided by 31. 31 and 18 doesn't quite work. So you keep trying these factors. Another thing to notice is that this does happen to have, excuse me, this was supposed to be a 64. That's why. That makes the difference. See? Gotta check your work. Sometimes you write down a number that's off. So 576. So you get 24 and 24 negatives, or what we'd need to add together and get a negative number. So we'd stick them in for this. So we get 9u squared minus 24u minus 24u plus 64. I hope throughout these videos you realize that even as a math teacher, I have to really think about and consciously check myself and look through problems, and sometimes I don't know the answer right off the bat and I have to brainstorm for solutions and just try something and see if it works. And so now that I have pairs of 4, or I have 4, I'm going to group them in pairs. In the first term, what's common is a 3u, and I'm left with 3u minus 8. In the second term, I can pull out a negative 8, and I'm left with 3u minus 8. So since these share in common, I have 3u minus 8. What I pull out front is the other term, minus v squared, just tags along for the ride. Since I have 2 identical, I can rewrite 3u minus 8 squared minus v squared. Now I have a difference of squares, so I take the first term minus the second, the first term plus the second, and it's factored. One last example of this type, x cubed minus 9y squared minus 27y cubed plus x squared. So you'll notice if I rearrange this, I have x cubed minus 27y cubed plus x squared minus 9y squared. So I just rearranged where things are at. So if I look at the front one and I look at the second one, it's two different things. You'll notice in the front one, I could rewrite this to be a difference of cubes. In the second one, I could rewrite it to be a difference of squares. So factoring my difference of cubes, I'm going to do it in a different color just so you can see it. I get x minus 3y, x squared, plus timesing them together, plus squaring the second term. Now, the plus from the middle, the second term, difference of squares, becomes x minus 3y, x plus 3y. You'll notice something now. They both have an x minus 3y in common. So I'm going to factor that out front, x minus 3y. What I'm left with is this term, xy plus 9y squared, plus this term. And I factored it.